Here's a quick summary of work and energy and some of their relationships. Work in physics is the product of force and displacement, the force applied and the displacement over which it is applied, but the two must be parallel to each other. Since the force and displacement must be parallel to each other, and we know that the cosine of 0 and 180 degrees are 1 and -1 respectively, we use this different equation sometimes. So if the force and displacement are parallel to each other and in the same direction, you get positive work. But if they're opposite each other, force is in one direction but displacement is in the opposite, you get negative work. This is Wow Wow and his patineta. And when that system is pulled forward, there is positive work done. Forward force, forward displacement, positive work. But at the same time, there's negative work done by friction because the friction force is opposite the displacement. And therefore, if force and displacement are perpendicular, there is no work being done. Cosine of 90 degrees is 0. If you take a real cart full of books, start pushing it down the hallway, it does require a continuous force from you to keep it moving because of the friction force. But the only force on the books is an up force, but the velocity and displacement are horizontal. So there's no work done on the books, but there is work being done on the cart by you. Same thing with Wow Wow. As long as he's moving at a constant velocity, then there's no work done on him, but there is still work being done on the patineta. Apply the same principles if you're pulling at an angle from the motion. So here's one situation. Work is force times displacement. You take the horizontal component and multiply that horizontal component by the horizontal displacement. Since they're parallel, that's one option. But you get the same answer if you take the hypotenuse, that force of 100 newtons, multiplied by the horizontal displacement, and multiply that by the angle between the two. In this case, it would just be 30 degrees. Whenever you lift something, we're assuming it's a constant velocity, work done by friction would be positive. They're parallel, they're in the same direction. The work done by the weight would be negative. They're parallel, but the displacement is up and the force is down. The net work would be 0. And since the net work done to an object is always 0 at a constant velocity, turns out that the net work, if there is some, is always equal to the change in kinetic energy. So it's net force times displacement is equal to the final kinetic energy minus the initial kinetic energy, where the kinetic energy is defined as 1/2 m mass times velocity v squared. Gravitational potential energy is just one of many kinds of potential energy. It turns out that the standard equation that we use is mgh, where mg is the weight. So it's weight times the height, which turns out to be exactly the same as the equation for work done to an object while lifting it, weight times height. So same equation, work done by lifting an object is equal to its change in potential energy, gravitational potential energy. And keep in mind a couple of general principles as we move forward. Work can be converted into various types of energy. Energy can be used to do work, but the net work done to an object is equal to its change in kinetic energy. And if there is any kinetic energy change, then that must have been done by a net work.